Hello, welcome to this live session. I am Bora. So, do you have any query? How do you like the course? So, this is a very important course. So, all the concepts are very important, and I hope you enjoyed the courses, the classes so far, lectures so far, and it gave the background, and then background of not only random variables and random processes, but also linear algebra, which is also very important for this course. And we are in the midway up to estimation theory. So, if you have any query, কিবা question আহিছে নে নাই? Yeah, that's a good afternoon. Something. When I can write here, no? Okay, good afternoon. Okay, so the question is like how to represent some data statistically. So you know that joint PDF is the model, or if it is discrete random variable, joint PMF is the model. Now question is how to get the model parameters. So for that we want the estimation theory, and it is a very well developed area, and there are specifically two parts, you can say. One is parameter estimation, another one is signal estimation. In parameter estimation, we covered so far what are the basic principles, like that estimator should be unbiased, minimum variance unbiased estimator, that is also one important concept. Then next we will see what are the principles like maximum likelihood principle, Bayesian principle, method of moments, etc. And we will also discuss least squares estimation procedure. There is another part that is signal estimation in noise. Normally we assume additive white Gaussian noise. So when that noise is there, how to estimate the signal. Okay, so now in that case, this is known as the filtering problem. We will discuss how to get the optimal linear filter using our knowledge about estimation theory. So that way we will get what is known as the winner filter, and then we will have what is known as the adaptive filter, because winner filter is a time invariant filter. So all the parameters are fixed. You have to determine them from the known statistics of the signal. But if the signal is changing, practically that happens only. So what you have to do? So for that, adaptive filter is there. You have to update the filter parameters according to the uh, signals, current statistics of the signal. Okay, so for that we have the adaptive filter theory, and finally there is another thing what is known as the Kalman filter. So Kalman filter takes care of like all the data available it will be using while developing the filter. So it is also one important topic and which is based on a model for the signal. So we have discussed about autoregressive process. So similar type of model is used in winner Kalman filter. So that will be our last topic. Okay. So do you have any question? Am I whether my assignments are easy or hard? Should I make it simpler or harder? Last year also I offered the course, so the materials are available in YouTube, but this year I am updating them, so you see the new videos only. Last video some means it is a modified version of last year's video, so that way these videos are slightly better, so that way you see. And any doubt you can mail to me also directly. My mail is in IITG website, you can see my mail and then you can mail address, then you can mail to me. So you have to revise that knowledge of particularly probability theory and linear algebra. Those are the two parts you have to uh, revise, like matrix theory, that is also important for this course. And normally there should have been an introductory lecture on matrix theory also, but I did not cover. But whenever this applications comes, I'll go back to the theory. Okay. So if you have any difficulty in this course, you can mail me, or you can post question in the forum, or uh, and this type of live session will be also there, so that way you can clear your doubt. And course is important, but and apparently a lot of mathematics are there, but it is not so difficult. All mathematics are uh, quite logical and very simple. It is some principles are there which are uh, simple principles, and that only used in different classes. For example, there is one orthogonality principle. So this orthogonality principle is very simple. I can illustrate to you. PowerPoint just a minute. So I'll explain one principle called orthogonality principle. Principle. Okay. So suppose I have to a line. I have a line and I want to approximate this line using another line. So I can approximate, suppose at this point, I can approximate at this point. But when the error, now this is the line and this is your approximation. Error is, this will be the error, like that. Okay, this will be the error. But if I approximate here, then error will be minimum. This is the error, so this error will be minimum. And if I come this side also, then also this error will be more. Error will be minimum only when this error is orthogonal to this line. Okay, so uh, uh, this is the principle that you know from geometry, that if we have to uh, get the shortest distance, then this should be a perpendicular. Okay, so the same principle now in terms of random variable, how I explain, suppose this is one vector and this is another vector. So if they are perpendicular to each other in inner product notation, that is E inner product of x is equal to 0. And if I consider in terms of two-dimensional vector, what is the result? Suppose E dot, if I consider this as a vector, E dot x is equal to 0. Now the same concept, if I have to consider in terms of a random variable, what it will be? That corresponding inner product is equal to E of E into x. So this is a inner product, just like dot product. This is an operation which satisfies similar properties with dot product. Okay, so I'll require that E of E into x is equal to 0. So if I want to approximate this vector in terms of this vector, then I will consider uh, this vector in such a manner, this scale part in such a manner that E of E into x is equal to 0. So this result is the orthogonality principle. This is same extension of very simple geometric principle, that shortest distance between two lines you can obtain by, suppose you want to approximate this line in terms of this line, then what will be the approximation, best approximation? You drop a perpendicular. So this same idea you see, it is extended to random variable, and that is used in our all filters like winner filters or even Kalman filter. Everywhere this principle will be used. Okay. So this is one principle we will be using. Similarly, suppose stationarity is one another principle. What is stationarity? So stationary means that suppose I have a uh, waveform. Now that waveform is single waveform only, but it is suppose I have a waveform like this. I do not have any deterministic model. Then we consider that it is a realization of a random process. Okay, one observation waveform, that is a realization of a random process. What does it mean? There are many possible likely values. Out of that, maybe this is one we are observing. Now, what does stationarity mean? Now, stationarity means that this probability structure, suppose when I consider examine at this point of time, there are likely values. Different likely values are there. Maybe this is another waveform, so this is one likely value, this is another likely value, this is another likely value, like that. Now you go to another instant. So maybe that another instant also that probability structure will remain same. So suppose this waveform has one probability, another waveform has another probability, this waveform has another probability. If we examine this, same probability structure will be repeated. So this type of notion will be used, and uh, but this is a that maintaining the probability structure or examining the probability structure at all possible instants of time, and that too in terms of joint probability is difficult. Therefore, we assume some simpler notion. What is that notion? White chance stationarity. What does it mean? Whatever you examine at this instant, the average value will be suppose some mu. Then you examine whatever possible values at this instant, that average value is also mu. That mu does not change with time. And then suppose this waveform at this instant and another instant, they have correlation. So what is that correlation? That because it is same random process, we are determining the correlation. Correlation is nothing but E of x t1 into x t2. Now this correlation, if it depends on only on the time lag t2 minus t1, it does not depend on absolute value of t1 and t2, then we say that this process is Whitehead stationary. Mean is constant, then autocorrelation is function of lag only. For example, suppose weather data. One example is weather data. Suppose whatever temperature today is there, and today yesterday was there. One day lag. So what is the joint? Uh, what is the correlation between them? Then you examine after 1 week, suppose same 1 day difference. If we get the same correlation structure, then we can say that these data are stationary. Mean anyway, mean has to be constant. So, but if we consider the weather data, then it is cyclically varying. Okay, so that way temperature, whatever we are getting, that will not be same in the month of July. So that way there is a seasonal component. So that part, if you subtract, for example, seasonal variation, suppose we can take care of that seasonal variance, and after suppose maybe 1 year lag, if we see the examine the data, then we will get the stationarity. So that way, how to get this stationarity? These are one of the or how to deal with stationary signal. That is one of the uh, aspect that we will be considering in this course. Okay. So you have any other query? Okay then, no query. Okay, thank you for watching. So if you have any query, you can post to me. Okay.